Welcome back, everyone, to another college algebra lecture. Today, we are going to finish up rational functions. As a recap of what we did last time, we said that rational functions are functions that look like fractions that have x in the denominator. And we've seen different styles. And the properties we've talked about before, we know how to find the domain of a rational function. Those are the x values that we're allowed to do. We can find vertical asymptotes. We can write the function in lowest terms. We can find any gaps or removable discontinuities. And we can also find the x and y intercepts. Today, we're going to finish up on the properties, which there are only two more to talk about. And then we're going to bring it all together and talk about how you can find every property and use those to graph your function. So to start with, we're going to talk about horizontal asymptotes. Now, horizontal asymptotes are very similar to vertical in that it's an invisible dotted line that your graph will follow. But this time they're horizontal, so they're going side to side. Now, another big difference between horizontal asymptotes and vertical asymptotes, for vertical, we saw that that was a line that our graph could not cross at all. But for horizontal, you are able to cross it. It's just as you tend out to the far right side and left side, or as x goes to negative infinity and positive infinity, your graph is going to follow along and basically match the line. Now, there are three different cases that we're going to see for horizontal asymptotes. And I know there's a lot of writing on here, but I kind of want to break it down in an easy way for you. The way you're going to figure out which of the three cases that you're in is you're going to look at the degree of the denominator and the degree of the numerator. And as a reminder, the degree is the biggest exponent. So look at the biggest exponent on top and the biggest exponent on bottom. If the exponent on bottom is bigger, so right here, if the bottom exponent is bigger, then your horizontal asymptote is the line y equals 0. So it's just going to be the x-axis. So you'll say bottom bigger equals 0. Another situation, if the degree in the numerator and the degree in the denominator are the exact same, then what you need to look at are the leading coefficients. So same over same equals leading coefficients. Now, the way this looks is you'll have y equals a over b. A is the leading coefficient of the numerator. B is the leading coefficient of the denominator. So all you got to do is look at the first numbers for each. Now, the last situation for a horizontal asymptote is if the degree on top is bigger by 2 or more. And that's a very important detail. I can't just say top is bigger. It's got to be bigger by 2 or more. So let's say you have 5 over 3 or 6 over 1. It's got to be bigger by 2 or more. If that is ever the case, then you just do not have one at all. You just say none. So 3 different situations. Now, here, if your top is bigger by just one number, say like 3 over 2 or 5 over 4, that's a different situation, and that leads us to our next property. And we'll get back to that. All right, so just like last time, I gave you the steps. What we're going to do is first look at the degree of the numerator and denominator and determine the horizontal asymptote. That's it, one step. But I did give you a big tip right here. Find the horizontal asymptote before writing the function in lowest terms. And even more, do it before factoring. So we're going to find this before you do any type of factoring. Look at the very original. All right. Now, these are very straightforward and very easy to do. So we'll go through these examples pretty quick. Looking at our first one right here, all I want to do is figure out if we have a horizontal asymptote. And the way we do it, don't factor, don't change it at all, just look and see what you got. Looking up here, I see that the degree of the top is 1, the degree on bottom is 2. So automatically I see that the bottom is bigger because my degree of top is 1 and the degree on bottom is 2. Since the bottom is bigger, I know that my horizontal asymptote is the line y equals 0. And there's nothing else to do. All right, now for the next one. I see before we do anything else that my degree of top is 4, my degree on bottom is 2. So here, the top is bigger by 2 or more. So right here, I can say that the top is bigger by 2 or more. Oh wait, that's backwards. Greater than or equal to 2. There we go. So since that's the case, I know that my horizontal asymptote, there isn't one. So just say none. There's nothing else to do. All right, now for this next one, I see that my degree on top is 6, my degree on bottom is 3. So yet again, my top is bigger, but I gotta make sure that it's bigger by 2 or more. Here, 6 minus 3 equals 3, which is bigger than 2. That's an easier way to go about it. I'll change that over here a minute. So 4 minus 2 equals 2, which is greater than or equal to 2. So that means that we just don't have a horizontal asymptote. Nothing else to do. All right, now looking at D, I see that my degree of top is 3, my degree on bottom is 3. That means that they are the same. Well, if they are ever the same, all you have to do is look at the leading coefficients. My leading coefficient right here is -6. My leading coefficient on bottom is 2. -6 over 2 is equal to -3. That is my horizontal asymptote. Y equals -3. Okay, now over here, I see that my degree on top is 2, my degree on bottom is 2. They are the same. So my horizontal asymptote is going to be the front numbers, 2 over 5. All done. And now for the last one. Right here, my degree on top is 3, my degree on bottom is 4. So that means that the bottom is bigger. And since the bottom is bigger, that means that my horizontal asymptote is the line y equals 0. And that's it. That's all you got to do. Finding the horizontal asymptote is probably the easiest thing for every rational function. All right, so now we have horizontal asymptotes down. We're going to shift over to another type of asymptote that brings in this other situation. What if the top degree is bigger by only 1? Well, for those situations, we are going to have what are called oblique asymptotes, or you might hear them called slant asymptotes. Either are the correct way of calling them, just depends on the book that you're currently using. So oblique asymptote and slant asymptote, same thing. And what these look like, these are asymptotes, so they're invisible dotted lines, but they slant. But what's special about them is you need to realize that these are of the form y equals mx plus b. It's a linear line. So when we find this equation for the asymptote, you're going to have something like this, y equals mx plus b. And as far as what they're going to look like with our graph, your graph will start following it just like it would any other asymptote. It might cross it, that's perfectly fine, but as we go further out, it follows directly beside it. Now, again, I gave you the case for it and the steps. If the top degree is bigger than the bottom by 1, that means we're going to have an oblique asymptote. Now, the way that we're going to do this, here are the steps. Step one, same as before. Look at the numerator and denominator. We're going to do this before factoring. Then we have to use long division. There's no option for this. You have to do long division. Synthetic will not work for us. But good news, you don't have to finish long division. All right. Now, I put a little heads up on here. A function will either have horizontal or oblique asymptotes. It will never be both at the same time because you can only be in one of the 4 cases. Okay, so let's see how we can find some oblique asymptotes. Looking at this one, I see that my degree on top is 2, my degree on bottom is 1. So my top is bigger. And as far as this goes, I have 2 minus 1 equals 1. So this one's oblique. Okay, so we will have to do our polynomial long division in order to do this. Now, if you are not comfortable with polynomial long division, I have 2 examples on here. And if these 2 examples aren't enough, please do a little bit of research online to find them. All right, so I have this x minus 2 on the outside. And on the inside, you have to make sure that everything's there, just like for synthetic division. So my biggest one is 2, 1, none. Everything's there. If anything was missing, I would have to fill in a 0. Okay, so now the way that polynomial long division works, you need to multiply, put something up here to multiply our outside by to make it cancel these numbers on the inside. The main thing you look for, what can I multiply my leading term by so that it matches this one? Well, the number I can multiply x by so it matches x squared is x. When you put this on here, you have to line it up with the degree that matches. So I have x times x gives me x squared. Then x times negative 2 is negative 2x. So again, I put this up here, and I picked x because I knew I could multiply by x, and it would match. Now, the reason I want this to match is because at this stage for long division, we have to subtract. So I will have to subtract right here by changing the signs. So I have x squared minus x squared. That cancels out. And right here, negative negative is a positive. So that is going to give me 6x squared. Now, if you don't like it like this, you can go ahead and change it right there. Okay, now we have to drop the 1 down. So I have plus 1 right here, and we do it all over again. So now I have to see what can I multiply x by so that matches 6. I'm going to have to multiply it by positive 6. So 6 times x gives me 6x. And then right here, I can stop because those are going to cancel and I'm done. This is going to be my oblique asymptote. You do not have to continue with everything. I get y equals x plus 6. And that's it. So we now have our oblique asymptote. It's the linear equation. And again, the reason I stopped is because anything else wouldn't have worked, or anything else wouldn't have been necessary. All right, so let's do this again. And again, if these 2 examples aren't enough for you, please do a little bit of searching online for examples on how to do polynomial long division. There's a lot out there. I highly recommend Khan Academy for certain things like this. All right, so looking at this, I see that my degree on top is bigger. So the top is bigger. And I have 3 minus 2, that equals 1. So that's going to be oblique. Okay, so I'm dividing by x squared plus 7x plus 12. And I'm dividing into x to the third plus x, or 9x squared plus 14x. Okay, so now let's figure out what we need to put. First thing I see is that I'm missing a term right here. I have 3, 2, 1, but I'm missing the none, so I need to put plus 0. Now, going through doing the rest of it, I need to multiply x squared by x so they can cancel with this. So I'll put my x on top of this one so they match up with degree. X times x squared gives me x to the third. X times 7x plus 7x squared. And then right here, x times 12 gives me plus 12x. Got it. Now I can go through and do my subtraction. That means this is going to change to a negative, negative, and negative. Those cancel. This is going to give me 2x squared, and those will give me plus 2x. Then I have my plus 0. Got it. Now, what I need to do next, what can I multiply x squared by so it cancels with 2x? I need to multiply by 2. 2 times x squared is 2x squared. When I subtract, they cancel, we're done. So my oblique asymptote right here is y equals x plus 2. Again, I do not need to finish the rest of it because that isn't necessary. All I need is the linear component, mx plus b. Okay, that's it. So now we've finished up all the properties. You now can figure out whether there's a horizontal asymptote by looking at the original function and the degrees of the numerator and denominator, and an oblique asymptote, which is also called a slant asymptote. Okay, so now it's time to bring all of this together. What we're going to do are problems where you have to analyze a rational function and graph it. So when we analyze these, depending on what book that you're looking at, they're going to give you different steps on what to do. The one that I'm going off of, these are the steps that I recommend. First, factor the numerator and denominator. From there, you can use that to find your domain. After the domain, you'll write it in lowest terms. Then, after lowest terms, you can figure out the vertical asymptotes and any gaps. Then we can do the horizontal and oblique asymptotes by looking at the original. And then we can finish with any intercepts. And hopefully you notice that except for the horizontal / oblique asymptotes, all of these went in the same exact order that we did in the previous lecture. So I had to go through all of these steps, but now there's just more room to work. The last thing you'll do is take that information and graph the function. Okay, so let's get started. Factor the numerator and denominator. Looking at this one, I see I can take a 3 out. So taking a 3 out, I now have 3, and then x squared minus 4 divided by, now this I can factor using the ABC method. Using the ABC method on that, I have, see here, I need to use positive 4 and negative 1. There, and plus 4. Now, I can go a little bit further. This inside is a difference of squares. So that gives me 3. Now I have x minus 2, x plus 2. Divided by x minus 1, x plus 4. Always try to factor as fully as you can because that's going to help you when it comes to doing your lowest terms. All right, so now figuring out my domain, I know I'm going to start my domain with a set of x's such that, then I look down here at the denominator. I see that I cannot equal negative 1, so x cannot equal, just 1, sorry. And then x cannot equal negative 4. That's something we can figure out really quick by looking at the domain or the denominator. Now for lowest terms, looking up here, nothing is the same on top and bottom, so it doesn't simplify. So it just remains the same. Now, if you're working this out on your own piece of paper, if it stays the same, you can just write the same. Doesn't matter. Perfect. So that means nothing got a little X under it. That's useful for us on this step, the vertical asymptotes. So as far as the vertical asymptotes go, nothing got crossed out, so both of them are going to be vertical asymptotes for me. So I get x equals 1 and x equals -4. And again, you can look up here or just look to see what's still an issue for my lowest terms. Now for a gap, since we didn't cross anything out, we don't have any. So there's none. Done. Okay, so now we can look at the oblique and horizontal asymptotes. What we're going to do is remember, look at the original function. So looking at the original function back up here, I see that I have degree 2, so that means that they are the same. If they are the same, I get y equals, here, it's 3/1. So 3/1 just reduces down to 3. All done. And just in case you need it, here you go. That's how I got 3/1. Okay, now for the intercepts. When finding the intercepts, I usually like to start with y. As a little reminder, when you're doing the y-intercept, we know x equals 0. So we're going to substitute x equals 0 into the lowest terms. So 3 times 0 minus 2 and 0 plus 2 divided by 0 minus 1 over 0 plus 4. Okay, doing some work on this. That's going to be -2. That's going to be +2. Multiply those together, we get -4. -4 times 3 is -12. Okay. And for the bottom, -1 times 4 is going to give us -4. We can reduce that a little bit further and get, let's not go down this way, 3. So I get 0, 3. All right, now for the x-intercepts, I look at the numerator of my lowest terms. So I have 3, then x minus 2, x plus 2, and I set it equal to 0. Well, solving this, I get x equals 2, and then x equals -2. So I have 2, 0, and -2, 0. Got it. We're all done. Those are all the properties and information we have. Now we're going to take that and graph. So when graphing, I'm going to give you some steps that I want you to follow, and it's going to help you out. So graphing steps. Step 1, all you have to do is graph the asymptotes. And when you graph the asymptotes, those are going to be dashed lines. So step 1, you have to put the asymptotes down there. Think about it as putting fences down that your graph has to stay within. Step 2, we are going to, I'm switching between capital and lowercase, graphing, we're going to graph intercepts. those will be closed dots, and gaps. Those will be open circle. The last thing we're going to do is we are going to finish using a calculator, because we get a graphing calculator for this, and that'll make it easy. All right, so on this one, I'm going to start with my asymptotes. I see that I have two vertical asymptotes. So my vertical asymptotes on here are at 1 and -4. So right here at -4, I'm going to go vertical by putting my dashed lines. And then at 1, I'll do a dashed line as well, up and down. Got it. My next asymptote is at y equals 3. So I'm going to go over here to where y equals 3. And horizontal means side to side. Got it. So I have my asymptotes on there. The next thing I'm going to do is I'm going to plot my intercepts. I see that I have a y-intercept at 0, 3. So 0, 3 right here. I have x-intercept at 2 and -2. And as far as a gap goes, I don't have any, so I don't have to put it. So I now know what lines not to cross, so I'm not going to go all willy-nilly crossing everything I want. And I have points to aim for when I'm graphing. Now to finish this, we're going to put the entire thing into our graphing calculator and use this as an outline. So putting this into whatever graphing utensil that you use. X squared, square, there we go. Plus 3x minus 4. Comparing them side by side, I see that this section of the graph is going to be in this part. This middle section will be right here. I have to go through, hit this point, hit that point, and then follow along. And then this last part is going to come up right here, hit the point, and then follow along right there. Now we have everything we need. So this one follows right around this way. This one goes up this way, hits that point, does not cross the line. And right here, this one follows the line, hits the point, and then follows along that line. Done. That's the graph. So the reason I want you to graph all these properties is because it's very easy to look at a graphing utensil and not be super accurate. But putting these asymptotes gave me boundaries to stay within, and putting the intercepts gave me points to hit so I could be more accurate. And that's it. That is everything for this. We've done all the properties and we've done all the graphing. So if you're good after this one, you're welcome to go on, but I do have 3 more examples to go over if you want to see some more. And one of those examples does include a slant asymptote, so it gives you something extra to look at for the division. All right, so onward to the next. I'll go through these a little bit quicker. So step 1, we're going to factor. So factoring this, I see I can take a 4 out. So I have 4, and then I have x plus 2. Next thing, for the denominator, I'm going to use the ABC method. For this, I see that I'm going to need to use -2 and +5. Wait, nope. +2 and -5, almost got that backwards. X plus 2, x minus 5. There we go. And all my factoring is done. Next step, domain. So I have a set of x's such that x cannot equal, looking at the first one, I see I can't have -2. And then X cannot equal, looking right here, 5. Got it. All done. Now for my lowest terms, I see I have x plus 2 as a factor for both the top and bottom. Crossing those out, I get 4 over x minus 5. Got it. Now, doing the same thing that we've done on the previous lecture, I crossed out x plus 2 and it completely disappeared, so I know this one goes away. That has been removed. You remember, removed equals gap. Okay, so now for my vertical asymptotes and gap, for the vertical asymptote, I see x equals 5 is still an issue for us. So I have a vertical asymptote at x equals 5. And then for my gap, I see that I removed the value -2. So to figure out the y value, I'm going to plug -2 in over here. So I have 4 over -2 minus 5. That gives me -4 over 7. All done. Okay, now for my next one, oblique and horizontal asymptotes, looking at the original, I see that the bottom is bigger. So since the bottom is bigger, I am guaranteed to have that my horizontal asymptote is y equals 0. Done. Now for the intercepts, starting with the y-intercept, let's see what we got going on. I'm going to substitute 0 in, so I have 4 over 0 minus 5. That gives me -4 over 5. Got it. So my y-intercept is 0, -4 over 5. For the x-intercept, I take my numerator, the lowest terms, 4, and I have to set it equal to 0. That is a false statement. So since it's a false statement, we have none. All done. We have filled in every bit of information that we can. So now let's take that and do some graphing. Starting up here, I do see that I have vertical asymptotes. So my vertical asymptote is at 5. So I'll go right here to where x is 5 and go vertical. Got it. Next thing, I see that I have a horizontal asymptote at y equals 0. Y equals 0 here, going horizontal. Got it. Next on my to-do list, gaps and asymptotes, or gaps and intercepts. So my gap right here is -2, -4 over 7. So -2 is right here, 4 over 7 is about right there. So I'm just going to put an open circle. Now for my y-intercept, I have 0, -4 over 5, which is about right here. So I put a closed dot. Got it. Don't have any x-intercepts, so I don't have to worry about that. Just looking at this, I can kind of guess that this graph's going to be down here. But as far as this side goes, most likely I'd be up here. But we can use our handy dandy calculator or whatever you're using for graphing to figure out the rest. So right here, I'm going to put 4x plus 8, and down here, x squared minus 3x minus 10. Just like I thought. This one's down here, this one's up here. So I'll follow along this line, careful not to cross it because I don't have any x-intercepts. And then I go down here. Then right here, I follow along this one, and it goes that way. All done. Nothing else to do. And it's very important that you do put the little open circle for a gap. or a hole or removal, discontinuity, whatever you want to call it. Put that on there. That's very important. That's it. All right, so onward to the next. So looking at this next one, we're going to factor. Factoring it, I'm going to see that I need the numbers. Let's see here. Positive 6 and negative 3. Got it. For the denominator, I see that they all have an x in common, so I can take an x out. Now I can do the ABC method. I see that I'm going to need negative 3 and positive 4. Got it. So now doing my domain, I know I'm going to have a set of x's such that x does not equal, looking right here, that's going to be 0. And then right here, x does not equal 3. And then right here, x does not equal negative 4. All done. Nothing else to do. Now for the lowest terms, I see that the factor x minus 3 can be taken out of both. So I have x plus 6 divided by x, and then x plus 4. Done. Now, just to help us out in a minute, I see the part that got removed is the x minus 3. So x equals 3 is removed. That's going to be my gap. So for my vertical asymptotes, I have x equals 0, and then x equals negative 4. All done. As far as a gap goes, we do have one, and we know the x value for this is 3. Figuring out the y value, we're going to plug it in. So I have 3 plus 6 divided by 3 times 3 plus 4. Doing this, that's going to give me 9 divided by, that's going to be 7 times 3, which is 21. Both of those can be reduced to 3 over 7. Got it. Gap finished. Now, as far as the oblique and vertical asymptotes go, I see that the bottom is bigger because my degree on top is 2 and my degree on bottom is 3. So in that case, I know that I get y equals 0. All done. Now, for my intercepts, I'm going to start with the y. Now, if you paid attention last time, you know I told you always be careful, look at the domain. Here, my domain, I cannot equal 0. So the y-intercept, I know I'm not going to have one. Right off the bat, I know there will be none. But just in case you think you might forget that, which that's a very easy thing to overlook with everything we're doing, I want to show you how you can help yourself out. Go ahead and do it. 0 plus 6 divided by 0 times 0 plus 4. That's going to give me 6 over 0 times anything is going to be 0. That is an error. We cannot have that. So there's none. So just in case you don't remember to look up here and see that you can't equal 0, it helped you out. All right, now for the x-intercept, I see that I can set my lowest term to numerator, which is x plus 6 equal to 0. Solving that, I get x equals negative 6. So I get negative 6 comma 0 as my x-intercept. All done. So finishing this up, I have 2 vertical asymptotes at negative, one's at negative 4. The other one's at 0. Then I have a horizontal asymptote right here at 0. Perfect. Now I can go through and plot any intercepts or gaps. I see that I have a gap at 3, 3/7. So that one is approximately about right here. So I'll put my open circle. Then my x-intercept, I have -6, 0. And remember, we can cross through a horizontal asymptote, so having a point right there is not an issue. Okay, there's no y-intercept, so I can just go ahead and type it in and see what it looks like. So graphing this one, putting that in, I have x squared plus 3x minus 18 divided by x to the third plus x squared minus 12x. Looking right here, I see that in this part, I'm going to start down here, hit this, and go up, because that's where my graph goes. Right here, this one will go up, and then come back down. And this one will go right here, touch that, and go this way. But I'm going to stay above, because there's no other x-intercept. So I'll start below, go up, and make sure I hit my point. Right here, this one goes this way, goes down, sounds a little funny, and then goes down again. Right here, this one goes through, hits the circle, and then follows along. All done. There's nothing else to do on that. Okay, so hopefully these are getting pretty quick. We've done these type of problems several times, and you can bust them out pretty fast. And the calculator helps a ton with this. Okay, one last thing, and we are good to go. So as promised, I have one that will have a slant asymptote. Okay, but before we worry about that, let's just take care of business as usual. So factoring, I see that I can factor an x out. After I factor an x out, I'm going to need to use the ABC method. So using the ABC method, let's see here. I'm going to need to use 4 and 6. And with 4 and 6, I want the 6 to be positive. So x minus 4, x plus 6, divided by ABC method again. I see I'm going to need 3 and 4. I want the 4 to be negative. So x plus 3, x minus 4. All done. So now for the domain, the numbers that I cannot equal, I see x cannot be positive 3, and then x cannot equal 4. Done. Now writing lowest terms, I'm going to remove the factor x minus 4 from both top and bottom. So my lowest terms, I get x plus 6, divided by x plus 3. So the factor that removed caused the 4 to be removed. Got it. Now for the next part, our vertical asymptotes, I see that x equals -3 is still an issue for us. So x equals -3. And then for the gap, let's see here, 4 was removed, so I know that's the value there. That's going to give me 4 times 4 plus 6 divided by 4 plus 3. So let's see here, that's going to be 10 times 4 is 40. And that's going to be 7. That can't reduce. So we get 40 over 7. Now when it comes to graphing this, getting a decimal approximation is going to be a little easy. Now for here, I see that the top is bigger. And the amount that we're bigger by, 3 minus 2 equals 1. So that means oblique. Oh, that's about that. There we go. So doing our division, I have x squared minus x minus 12 on the outside. On the inside, I have x to the third plus 2x squared minus 24x plus 0 to fill in the missing part. Okay, so remember, I have to multiply x squared by something, so it cancels with x cubed. I'm going to multiply by x. So x times x squared is x to the third. X times negative x is negative x squared. X times negative 12 is negative 12x. Now, going through doing our subtraction, that's minus, plus, plus. So those cancel. That is going to give me 3x squared, and right here, minus 12x plus 0. Now for the next part, I just need to cancel this one. So I'm going to multiply by 3. 3 times x squared is 3x squared. Doing my subtraction, they cancel out. We're done. That's our answer. So we get y equals x plus 3 for the oblique asymptote. Done. Hopefully you don't think these are too terrible. You don't have to finish the entire division part. Okay, now for the intercepts, I'm going to start with the y-intercept. Checking up here, I don't have 0 removed from my domain, so I know I can have one. Filling it in, I have 0 times 0 plus 6 divided by 0 plus 3. Well, 0 times anything is just going to be 0. And 0 divided by 3 is still 0. So I get 0, 0, the origin. Now for the x-intercepts, I have x times x plus 6 equals 0. Solving that, I get x equals 0 from this one, and x equals negative 6 from that one. So I have 2. 0, 0, which we already knew, and negative 6 comma 0. Perfect. So now we can go through and graph everything. Doing our asymptotes, I see that I have a vertical asymptote at negative 3. So right here at negative 3, I'm going to go up and down. Got it. Now for the oblique asymptote. This is a line, y equals x plus 3. So the y-intercept is 3 right here. And my slope is 1. We've dealt with graphing these. So I'll go up 1 over 1. So up 1 over 1, dash, dash, dash. There we go. And now going the other way, same thing. That's our oblique asymptote. This is the line y equals x plus 3. Okay, now we can put our gaps in intercepts. I see that I have an intercept right here at 0, 0, and then one again at negative 6, 0. Perfect. And as far as a gap, I have one at 4 and then 40 over 7. So 40 divided by 7, let's see here. That is 5.7. So we're just a little bit above 5. So I'll go to 4. And then right here, that's 5. So it's about right there. Got it. So now we can finish it up. Finishing this in here, I have x to the third plus 2x squared minus 24x divided by x squared minus x minus 12. Check it out. It looks like what we have. And you can see that we follow along that slant asymptote. So I follow along over here. I hit that line, and then I go up. And right here, I follow along this one, hit that point, hit the dot, and then I just follow along. All done. That is how you can graph using a slant asymptote. And we are finished with this lecture. So at this point, you now know all of the properties that you need for rational functions. You can find the domain. You can write it in Lewis terms. You can find vertical asymptotes and gaps. You can find horizontal and oblique asymptotes. You can find x and y intercepts, and you can graph it. If you have any questions about this material, please feel free to contact me. I'm always happy to help you out. Other than that, have a great rest of your day.